Let me introduce myself. I'm Ashwati, Assistant Manager in HR and Operations at Inntot Technologies. I have been with Inntot for more than 3 years, and today I'll be managing the role of moderator of this webinar. Now it's time for our key speaker today, Mr. Sri Prakash, who is handling topic today. And I would also like to extend my thanks to Kerala IT for giving this wonderful opportunity to take this webinar on the topic digital broadcast, radio evolution and emerging trends in modern communication system. And before starting the session, I would like to say a few words about Kerala IT Park. Kerala IT is a hub which provides a platform for IT professionals, companies, investors, developers, and service broadcasters, with providing a world full of opportunities which accelerate the growth and development. It also follows a hub and spoke with Trivandrum Technopark and Cyberpark in Calicut, Infopark in Kochi, and spoke as Kollam, Chertala, and Korati. Then let me proudly introduce our company profile. All right. So we started our journey in 2014, and we are actually focusing on research and development company having IP solutions in the domain of broadcasting, which is more than 2 lakhs receivers of major brands. And we are also licensed digital broadcast receivers IP solution to Tier 1 customers like Clarion and Telechips. Inntot also providing IP-enabled engineering services in the domain of automotive infotainment and connected intelligent transport system, then advanced driver assistance system. And we are consist of 33 employees, and we are all doing our work in our corporate office, which is located at Infopark Phase 2, Jyotirmaya, Kakinada. And we are also having a representation in Japan and US as well. And coming to awards and recognitions, we received awards from NASCOM, NXP, National Technology, DRM Enterprise, then Associum, CIA. Now, again, I would like to introduce our key speaker today, Mr. Sri Prakash. Even though we are having a busy schedule, having a lot of projects in hands, he has taken this opportunity as a challenge and dedicated his time and effort to come up with ideas, and he'll be showing up a few information which will be definitely beneficial to the attendees and current market. Prakashi is one of the most talented and enthusiastic person in our team. He is managing our enthusiastic engineers as well, and he's been with Inntot for more than 1 year. Then before starting the session, I would like to request all of you to mute, and I think you all already have done that. And if you have any queries and questions while session is on, you can keep on typing chat, and we'll be take up a few more questions in the 10 to 20 minutes, last 10 to 20 minutes. And I hope it will be beneficial to all of you. And let's start the session. Just waiting. I think now it's Prakash, it's all yours space, and it's all the best.
Okay, thank you, Ashwati, for the kind words and handing over that. Okay, hi everyone. I'm Sri Prakash. I work as the Senior Engineering Manager in Inntot. Before we start, I would like to thank Kerala IT Parks for giving me this opportunity, the wonderful opportunity to present such a session with such a august audience. So let me start. I share my screen. Okay, so the topic is today what I intend to cover is about digital broadcast radio evolution and emerging trends in modern communication systems. So emerging trends in modern communication systems is a generic topic, but what we intend to, that's a huge topic to cover. So what we specifically intend to cover is what is called as software defined radio. As part of this emerging trends. So coming to digital broadcast radio evolution. Okay, before we start on the specific digital radio broadcast evolution, the topic, I would like to just go through this radio frequency spectrum. So that when you talk about radio, I mean it's a huge spectrum or a huge number of topics or applications and domains which will come in. So I basically want to set the narrow down on to the areas which we are intending to cover in this session. So looking at this radio frequency spectrum, you can see it ranging from less than even 3 kilohertz in frequency, ranging all the way upwards of 300 gigahertz. So like maritime radio or navigation, which is operating in the very low frequency, moving upwards, the broadcast radio, which we are mainly focusing on, the medium frequency, high frequency, the short wave radio range, that is the broadcast radio spectrum. Then moving to the television, very high frequency, and all the way up to satellite communications and Wi-Fi, which are extremely higher frequency range. So among this spectrum, in the first topic, which I want to cover, which I intend to cover, is the our good old radio broadcast, but what is called as a digital radio. So we'll be mostly sticking to the medium frequency, high frequency area of this radio frequency spectrum. That will be related. That will be mostly related to the broadcast radio. So this is a simpler, even more simpler view of the previous slide. So here you can see the frequency spectrum from a low frequency up to UHF range. So you can see the AM and FM mentioned just above the red bar. So basically, to start with, what is digital radio and where it operates, or where it coexists or exists in comparison with traditional radio. So that is what I want to start with, because most of people may not be aware of what digital radio really means. The first point is that it is not internet streaming. So we do get a lot of radio stations on internet, but that is not what is called as a digital radio. But it is our good old traditional broadcast radio, but in a new avatar. So how does it differ? We'll come to that. So if you look at the diagram, the red band, so that is as an example. I mean, that is where the digital radio operates uh, in conjunction with AM and FM. So it operates in the same bands AM and FM operates. But the difference is that you are sending digital content over the same spectrum, same radio frequencies. So basically, it is a high quality digital replacement for the analog radio, traditional analog radio. So it is broadcasted as seen from the figure in the same AM, FM, VHF bands. As an example, I have taken DRM, which we'll come to in the next slides. DRM is one of the technologies used among multiple technologies used by worldwide. So the digital radio, it is operated with the same channeling and spectrum allocations as currently employed. That is one of the reasons that is advantageous, so that the migration to digital would be easier. Now, I hope I'm clear, made you clear with what is digital radio and where it operates. So just to reiterate once more, digital radio operates in conjunction, it coexists with AM and FM in the case of DR to start with. So now coming to why digital radio. There are many advantages, substantial advantages over traditional analog transmission. Once anything you get digital, you get a lot of flexibility. There are immense unlimited possibilities. So that is why mostly the regulators are now insisting on adapting digital radio going forward. So we'll come to the market penetration and reach in the subsequent slides. But just to start up on few important points. One of the important points is you can transmit multiple services or channels per frequency in digital radio. Second, the advantage could be service reliability. High quality codecs are being used, so the audio quality is vastly improved, especially even on the AM band. Then usability. Then there are a lot of flexibility, which due to the technologies used in digital transmission, it offers flexibility for the broadcasters to adjust to the varying conditions. Then error control is possible to improve the quality. Then there are a lot of savings on transmission power and coverage as well. So these are few of the important advantages when it comes to digital radio. Okay, to start with, to make you aware of the different technologies used worldwide. So the first one is digital radio Mondial. This is one of the technologies popularly known as DRM. This is what the technology adopted in India and a few other countries like Russia, South Africa, and others. So it works across all broadcast bands. The other important one is digital audio broadcast DAB. It operates in VHF3 band across Europe, mainly Great Britain and other European countries. So it provides the ability to, as I mentioned earlier, the digital radio, the most important thing is that you can transmit multiple services or channels in a single frequency. So in case of that, we can, it has the ability to run up to 16 programs or channels in digital only mode. And DRM can do that for 3 services and even data services. Next is HDR, HD radio for adapted for America, that is North America, Canada, and Mexico, and Panama and Philippines. It can also run up to 15 channels in digital only mode. Next is CDR, which is China digital radio in the China region. So these are the important key digital radio technologies adapted worldwide as of now. And you can see Australia, you have DAB, and South America, some DRM, and different geographies are in the process of adapting and moving into a digital domain, even in the broadcast radio. So, talking about current state of digital radio adaptation, if you start with China, there are around 560 CDR stations already operating. HD radio, the reach is around 400 million, mainly in North America. So, and one of the major traction points you have on digital radio is more than consumer digital radio receivers. It has got high traction in the automotive domain. So, more than 75 million cars for HD radio in US and North American market, and you have around 2,700 radio stations already in the North American market. DAB, talking about the DAB reach, which is for the Europe, it's around 420 million because there are more than 100 million DAB receivers. And as I mentioned earlier, it is mainly for Europe and Australia. DRM, which we follow in India, we have more than 5 million devices already, 33 plus stations, which gives a range of reach of around 600 million in AM and shortwave bands. So these are the current state of adoption, digital radio adoption. Okay, so to start with traditional, just to go further into the technicalities or high-level technicalities of digital radio transmission and reception. If you look at a traditional radio broadcast chain, it's more of a single frequency, single service. So you have your audio signal coming from the microphone, and on the transmitter, it is modulated onto a RF carrier frequency and transmitted over the air. So on the receiver side, you receive the signal. It is demodulated, and your original analog signal, the audio signal is fed to the speaker after amplification and some other processes. So this is the normal broadcast chain in traditional analog radio broadcast chain. So coming to digital radio broadcast chain, again I have taken DRM as an example. More or less other technologies also follow the same steps or steps. So this this picture on the right side, it's a single service, single transmitter broadcast chain. It depicts the general flow of different classes of information. So one thing, as I mentioned earlier, it is with digital in place, what we can, instead of just audio being sent across, we can send audio, data, and other information as part of radio transmission. So if you look at the left side of the blue boxes in the second picture, you have the studio where you get the audio and data which is fed into a content server, where it is encoded according to the geographies and the specification to receive the, and it is multiplexed into a bit stream basically. So which means your audio data and other frames or tables which are required for on the receiver side for extracting these separately, they are all multiplexed together into a bit stream and fed into a modulator. So this digital data, the digital bit stream, is then modulated using what is called as OFDM technique. In case of digital radio, most of the digital radio technologies, orthogonal frequency division multiplexing. So using that technique, it is modulated on to an RF carrier and transmitted over air. So once on the receiver side, once the antenna, the signal is received on the receiver side, and the front end or the tuner removes the carrier, and the modulated signal, which is the baseband, so that is fed into the DRM demodulator. So, or since this is an example with the DRM, so on the demodulator side, there are a lot of signal processing which happens with respect to extracting the different streams or tables and the components. So all those signal processing is applied most probably usually on the with some dedicated chips or SOCs, which result in the original bit stream. So that bit stream, which contains all the audio data and other information, that is fed into the demultiplexer, where it is separated, or from high level terminology, I mean, it is separated and processed by different modules. Like the data is processed by the middleware or the software part of it, and to generate the information and update the database and such thing. The audio data is fed to the decoder, and other data is again processed by the service, that is the information regarding the services, etc. So the audio is finally fed to the speakers. So that's how basically whatever the audio and data which was received or generated at the studio goes all the way over, receives at the receiver, and it is sent to the output, which is on the speaker and maybe even an application UI. So this was a simple broadcast chain just to make you aware about the flow. So one of the main advantages, as I mentioned, with respect to digital broadcast transmission, is that you could have multiple services in a single frequency. So as an example, whatever I have shown here is the AM frequency, that is digital data sent over AM. It could be it is the same for FM as well. FM, I mean digital broadcast over FM band. So traditional analog radio, if I see, it is like one service per RF frequency. So at 531 kilohertz, you can transmit only one channel. So in case of digital broadcast, you have multiple services coming in at the same frequency, which means you are saving a lot of cost on with respect to transmission and even on the receiver side. So this is one key important advantage which you should be aware of going forward. Okay, so just wanted to highlight the main important advantage, and coming to other advantages, we can classify them from 4 perspectives: listeners' perspective, manufacturers, broadcasters, and regulators. So from a listener perspective, what are the advantages? You get near FM quality for AM reception with most advanced codecs being used. So you will be aware that most of the time even in automobiles we use FM, but we hardly use AM because the quality is generally very bad or the reception is bad. But with digital transmission over AM band, we still can achieve near FM quality. So that is one major advantage. Then there are other flexibilities like you have what is called as automatic frequency checking and switching, which allows receiver to stay tuned to stay tuned in adverse conditions. So automatically the services will be switched across frequencies for there is a seamless transition. And as I mentioned, you have possibility of transmitting 4 or more channels based instead of 1 in analog. So 4 or more means it depends on the technology used. So four services up to 16 or even theoretically 32 channels are possible. Then you have possibility of transmitting data applications such as EPG, electronic program guide, which helps to which explains about the program and details and the album or whatever songs and all those things. Then journal line, which we'll come to later. Then alarm or warning announcement. Then even traffic updates. So these are the important advantages we get from a listener perspective. From a manufacturer perspective, basically it's a huge opportunity for new market, because there are, with the number of new cars being sold every year and across geographies, and most of the governments insisting on or adapting to digital or mandating to adapt to digital. That's a huge opportunity for manufacturers. Again, increased market potential, possibility of new areas of interest. So once things are digital, the flexibility and opportunities are limitless. So you have potential for hybrid radio. I mean, it's not potential; it's already systems are in place. Then seamless switching between broadcast radio, and if the signal goes bad, you can switch to IP seamlessly, so that the user experience is not going bad. So you have a better user experience. From a broadcaster's perspective, you have multilingual programs and other information, extra information which you could transmit. And of course, as I mentioned, I mean, by the fact that you can transfer multiple services in a single frequency, that itself will reduce the power consumption as well as cost. But the fact that it is digital technology with the underlying different technologies used, it is reducing the power consumption even by more than 40 to 50%. Then again, from broadcaster side, there are a lot of opportunity for new revenue generation streams, of course, with advertisements and data applications. From a regulator's perspective, it is more or less, some of them are the similar advantages because we use less spectrum because of the flexibility for transmitting multiple services in a single frequency. So the freed spectrum could be used for other purposes from regulators or government perspective. Then the lower power costs, which is anyway advantageous. Then there are possibility for transmitting emergency warning alerts for notifying about disasters or impending events, and which is cheap and best way even now for reaching out to the masses. So, okay, so I'll touch upon few of the additional features. Okay, I'll start with this. One of the major important advantages or additional features is that it's about emergency warning. So it's basically to the whole framework of digital broadcasting. It integrates disaster and early warning services called emergency warning functionality with respect to DRM, and there are similar frameworks available in all the technologies. So the intention is to inform the public about any impending disaster with maximum reach and as quickly as possible. So, and also to reach out to all section of society, even foreign language visitors and people with impairments. So, with respect to emergency warning, if you look at the features perspective, what is very important is that one of the major important, it can even wake up the unit or the receiver from standby to alert about the emergency situation or the message. So it can throw with displays available with the receivers, it can throw up a visual alarm indicator with text, and it can even if you're tuned to some particular frequency, it can forcefully switch the frequency, switch the current receive frequency to the frequency which on which the emergency warning is transmitted. So, and auto volume increase is available. So it's like forcefully making you hear the emergency warning. So the warnings are received as audio program, text messages, and advanced text service called journaling, and in multiple languages. So these are all very important feature or advantage of digital radio broadcast, especially with the last earthquake in Turkey and Syria. In that context, it highlights the importance. Okay, going forward, there are still more additional features like sending text messages, short text messages, and even basically which it could be related to the current audio service you're listening to, maybe the song title, artist, and station, news, etc. So okay, apart from simple small text messages, there is other feature called journaling. So this could be, this could be signaled as part of the audio program or as a standalone service. As I mentioned earlier, you could transmit multiple channels or services and data services as well as part of single frequency. So in this case, the user is provided with a selection, multiple options, information topics, which you can navigate through the topics and select and go through the whatever you are interested in. So it's a more advanced feature with respect to text information service. So, yeah, another feature is for traffic. It's some one of the technologies is called TPEC. It's a framework for carrying basically carrying information for end user devices with respect to real-time traffic information. So it's generally called as a silent data channel because users are not. It is unobtrusive because users are not disturbed because it's continuous stream of data is coming and it is processed separately in parallel simultaneously along with the decoding, audio decoding, and there is no interference. So it provides more or less similar functionality which we are aware. You get updated traffic information delivered in real time. There is no need to wait for separate announcements. Instant knowledge of accidents or traffic jams, filtered information only for the immediate route, information in user's own language, high quality transmission, global compatibility for different receivers, all those things. Okay, then further you get service and program information again with respect to the current program genre, navigation, I mean, selection, all those things are possible. You get, there is even support for slideshow as a sequence of images, again, typically related to the current program you are listening to. So it could be a program logo, album cover, and most of such information, even news related information could be transmitted. Okay, from broadcast perspective, the market, digital radio market, if we quickly go through, European Union has mandated that all new cars sold must have digital radio receivers. So, yeah, over 95% of new cars in key important European markets now support digital radio broadcast reception. So that is a huge opportunity from a broadcast and even from receiver perspective. Okay, coming to India, India has mandated DRM 30 for medium wave shortwave bands, and for FM band as well, it is in active consultations for adoption. So there are already around 39 digital stations, and full analog switch off proposed by 2024, which I'm not sure if that's going to happen, but definitely it is going forward. That's going to happen. Don't know exactly. The timelines are up to date. Again, as I mentioned, there are already around 560 stations in China. Huge number, 4,200 stations already in USA, Canada, and Mexico. 391 in Australia, that New Zealand, that region. And actively the transmission is ongoing. South Africa, the transmission is mandated actually. So policy in place, and they follow, they plan, they use DRM in all bands. Also, okay, DRM in all bands and VHF3 DAB. Russia again adopt DRM in medium and shortwave band, and DRM in FM band. Okay, and several other countries are in transformation as well. Okay, that was from a broadcaster perspective. Coming to from a receiver perspective, it has got maximum traction on, as I mentioned, in the automotive domain, but even smartphones and consumer receivers are getting popular, or there are growth prospects even on those side. So if you consider automotive market size for over 5 years, it's more than 250 million units. It's a huge opportunity. Smartphones, it is expected to be supported in smartphones, primarily maybe Android. And consumer is not having that much of traction, but it's still in focus. Then with respect to the technologies, as I mentioned earlier, more than 120 million DAB receivers, so huge market. 15 million cars sold in Europe each year, so 1 million in Australia, so and 2 million in Middle East and North African regions, so which provides a huge market for receiver manufacturers. DRM, you have 4.7 million cars stores in India already, and around 4.4 million cars sold each year. And the same with South Africa, Russia, and Indonesia, such adaptations. CDR 560 stations, 24 million cars sold each year. So same with HD, this 4.7 million cars sold each year, and more than 50 million cars are already equipped with HD radio. Same thing from receiver perspective, the fact that analog sunset is imminent and digital switchover will happen. So based on that, beneficiaries, a lot of benefit from a common man, broadcaster and regulator perspective. And the sectors impacted, as I mentioned earlier, not just automotive and entertainment. We have education, disaster management, and all getting impacted because there are a lot of improvements which are adaptations which are coming into education for children education and with the digital radio transmission. Same with for disaster management, anyway, we covered. Okay. Moving on to the second part, which was the software-defined radio. So this till now we were focused entirely on the broadcast radio, but software-defined radio, here the radio could cover the entire radio spectrum. But as since we work on the broadcast radio, the subsequent slides as well would be more or less focused on that, but it is applicable for the entire radio transmission. So, so what is software-defined radio? It's like defining a new approach. Not really a new approach in that sense that it was already prevalent or thought process was already ongoing for a few years, but it's got more traction now because of improvements or the improvements on the processing power for the main CPU or host processor. So if you consider a radio communication system, especially from an analog hardware perspective, there are a lot of components like mixers, amplifiers, modulators, filters, demodulators, all implemented or as part of your receiver hardware, which was doing a lot of signal processing on the received signals. But all those processing now can be performed on a host processor or GPP, general purpose microprocessor, so which can work on the raw digital stream to achieve the same functionality, basically. So what it means is that we could replace many of these hardware components to achieve the same functionality when we move into software-defined radio. So okay, so just to compare traditional solution and an SDR solution, as we mentioned earlier in the one of the earlier slides, we have the RF signal which is received on by the antenna, and you have from the baseband signal coming out of the tuner. If you see the left side, that entire processing of that was done by specialized digital radio chip or SoCs to do all the multiplexing, demultiplexing, demodulation, all those things, and decoding. All those parts were done by separate digital chips, radio chips, and the output of which were mainly the audio data and other tables. That was processed by the middleware or the software and used by the applications for the end solution for the product. But the same thing on the right side, if you see all those things, the specialized digital chip is now removed. I mean, directly the baseband digital signal directly is handled by the host processor. So the demodulation, channel decoding, all those functionalities which were earlier done by the dedicated chips are now handled in the host processor. So that is the main difference with respect to SDR. Okay, coming to the benefits or why SDR, it's basically the solution is software based and does not require hardware based solutions. So what happens is that your host processor or main core or whatever you call it, in most of the embedded solutions or other solutions, you have a lot of leftover processing power. So it is it's about utilizing that, and not just that, there are a lot of optimized high performing instruction sets available to do digital signal processing as well as part of the main core itself. So that helps to remove a lot of traditional hardware components which were necessary. So, but it is highly optimized for, I mean, based on platforms mainly for ARM and easily configurable. So there is huge savings in BOM, bill of materials cost, because you're removing a lot of hardware components and implementing all those functionality in the software main core itself of the host processor. Another advantage or benefit is that this being software, it is easily upgradable. Software upgrades are possible, which is not possible with respect to hardware-based solution, and it is easy as well and configurable. And on top of it, yeah, there is a lot of shortage of chips, hardware chips. So those things are unaffected with SDR solutions. But the challenges for SDR, you need to write efficient code and pretty complex code which to achieve the same functionality. So very effective software implementation is required. And it is closely tied with architecture with your host processor architecture and platform. And you definitely need a highly qualified and expert team to handle that. So those are the challenges. But if you weigh both of these, it's getting a lot of traction of late, so that the amount of cost saving is far overriding the challenges, and it's moving forward towards SDR in many cases. Yeah, the same thing as just mentioned. It's highly cost effective, flexible, high performing. And these are all applicable, not, as I mentioned earlier, not just to broadcast radio. It is applicable for wireless communication, satellite, military applications, IoT, asset tracking, wildlife tracking, because you have volume business. And when you have volume business, cost saving, even small cost saving, is a huge saving for the from a product perspective. And enormous application. The market size today is around 24 billion USD. By 2030, it is expected to be around 50 billion US dollar. Okay, so coming to our company, Inntot, so and our solutions from a digital radio and SDR perspective. So we have universal digital broadcast radio receiver IP solutions. So it's a entirely software-based solution, and you don't require the demodulator chip and other hardware SoCs. So huge savings with respect to BOM cost, easy software upgrades, and it is unaffected by, as I mentioned earlier, the shortage of chips. So, and we have highly optimized the SDR solution based on the platforms, and especially from ARM perspective, by utilizing the advanced instruction set of the platform or the chip offers. It is less CPU intensive, and we have market leading timing performance comparable better than even hardware solutions. And we've been granted with 7 patents on these, and 2 are pending, and others are in the process as well. So it's already ported to several ARM processors and integrated with several automotive grade and consumer grade tuners. Sorry. Okay, and we have designed our solution such that it is it's a universal radio receiver irrespective of technology. The technology is abstracted out, and it's a one-stop shop for DRM, DAB, CDR, and SD receiver solutions. It's fully functional with recommended and optional features, fully compliant with digital radio standards, and already productized and deployed for 3 high-profile customers. Okay, and about our progress again, there are 3 major customers, including for Asia, Clarion, and we have already launched our IP solution in Indian market through latest car models of 2 major car makers. More than 200,000, that is 2 lakh cars of 2 major Japanese brands are using our solution in their high-end cars. And a lot of collaboration with major tier ones are ongoing, and it supports automotive, consumer, and smartphones as well. We have solutions in all these, and we are our DRM and DAB offerings. I mean, we have SDR-based DRM receiver solution ported to, as I mentioned earlier, multiple processors and multiple automatic grade tuners. Consists of hardware, software solutions for the earlier hardware components like demodulators, decoders, and then of course whatever software handling to be done on top of the data, the middleware and data services, and it's available in all major 3 domains: automotive, portable radios, and smartphone. And we have field tested in several Indian cities and licensed already to multiple customers. From DAB also, similar story. Specifically, okay, it's all supported across multiple platforms, SoCs, and operating systems. And Inntot, we are a member of the DRM consortium, DRM Technical Committee, DRM Stakeholder Group, and winner of DRM Enterprise Award 2019 and World DAB as well. We are a member of World DAB as well. Okay, these are a few screenshots of our receiver solutions with the reference UI. I mean, it's just some reference UI. So you can see this is a DAB solution. It has all the information available. Because we have designed our solutions such that, as I mentioned, the interfaces are common or generic for across technologies. So you have all the information required for the applications or to productize is available as part of our interface design. This is the screenshot of DRM receiver solution, and that's the picture of one of our consumer receiver. This is This is again UI from consumer radio and the Android solution of Inntot. Okay, let's just highlight that we are into these domains, the automotive, consumer, and mobile. Okay, so that more or less concludes my session. So Ashwati, maybe we can move on to.
Hi, Pranashri. I think we have one question in the chat.
Okay.
Manu has asked that can I add closed captions or media data like data along with audio files?
Yeah, I have already shown the text closed captions. Okay, real time.
I think Manu.
Okay, text data is possible. So with the same, I need to check that specifically from real-time data. But text, there is already a framework available for transmission of text data, so that should be feasible. Because that depends on the real-time transmission for the audio. I mean, the text for the audio.
Okay. Then if anybody has any questions and all, please feel free to type onto the chat. We'll be having few more minutes left. And also, let me check that. And also, Tyagarajan Radhakrishnan says, good evening all from All India Radio, Chennai. Good evening, sir. Manu is asking that what is the scope and challenges on Indian market?
I just saw that. As I mentioned already, I mean, the scope, it's got huge scope because already our solution itself is already in the market for more than 200,000 cars. So it's bright. That's what I would say.
Okay, Manu, I hope your question is clear. If anything else, please let me know. Yeah. Yeah, Nanta Kumar said that thanks for the excellent webinar. Thank you.
Oh, thank you.
Okay, few more minutes left for question and answers. Okay. Radha Krishnan is asking that I have a generic question. Since everything is moving around artificial intelligence with the help of AI, is cross translations possible in DR?
Can you please repeat? Since everything is moving around AI.
With the help of AI, is cross translations possible in DR? I think
I couldn't hear that.
Cross translations. He's mentioning that with the help of AI, is cross translations possible in DR? I think he's asking that will AI help in cross translations in DR? Something like that. Radhakrishnan, could you please make clear your questions? Translation from one language to another.
Oh, okay. That is, see, that is all from an application. as far as I am aware, I don't think there is anything from a specification or regulator broadcasters perspective, but these are all application features. So with AI, anything is possible from a digital processing perspective, right?
Okay. I hope that makes clear your question, Radhakrishnan. And Abhijit is saying that thanks for the seminar. It was very informative regarding the modern communication. Thank you, Abhijit. Okay. Anybody else have questions? Please feel free to ask. We have, I think, 5 more minutes for. Okay, Manu is asking another question.
I saw the question, so I guess Manu, I think it's way beyond the scope of this session about why the government is pushing onto automotive, because anything anyway, being digital, if it has a lot of advantages, why not? If you have seen all the advantages, and especially from a government perspective, at least for emergency warning and such features, it's very important that to better to adapt to digital world.
Okay. And we have few more questions in the question and answer session. Prakashi, could you please check on that? Abhijit is asking that all mobile phones have FM radio, but still there are lack of informative or news content through it. Why regulatories are not interested in such platform?
All mobile phones have informative, but the lack of informative or news content through it. Okay, all I can say is, again, it is a bit more outside the scope of this session, I would say, because anything related to regulators and things is a bit dicey to answer from a individual or from a single point of view. So we hope that these get streamlined, and there are more and more traction from mobile phones, as well as consumer devices, and the costs come down as well. But I think that will happen.
Okay.
On the manufacturers as well, right? For the content, yeah, not specifically, but I think it will evolve from the automotive experience to mobiles as well. But from a regulator perspective, connecting to that, I can't answer that.
Okay, there are a few more questions from Sri Prakash and Gayatri Prakash, which will be followed by.
There are multiple services.
With the last
I am reading it. What are the challenges? Okay, for multiple services with respect to no, the underlying, all I can say is all the underlying technology will handle those, because it's like multiple what do you say, multiple pipes within a pipe, and all mutually exclusive. So again, from a security other perspective, it all depends on the regulations, and it will evolve in due course.
Okay, we can conclude by checking two more questions, which is from Gayatri.
No, that's what I answered.
All right, then
Yeah.
we can go for webinar chat question from Renzi. Do you have any products or solutions for academia for teaching or learning process like that?
Okay.
From chat.
Teaching or learning. Product, no, not yet. But we have it's a IP solution, so it's all about uh, adapting it to any specific platform. So it is feasible. We have not specifically done that, but it is possible, easily possible.
All right, I think we have no few more questions, and thank you, Manu, saying thanks. Thanks, Manu, Gayatri, Sri Prakash, Abhijit, everyone who asked questions. And I think it's time to wind up. Thank you, Prakashji. If you have any questions or queries related to this webinar, kindly contact to us through LinkedIn or our company website. We'll be getting in touch with all of you. Yeah, thank you. Thank you.
Thank you everyone for joining. Okay.
Prakashji, can you please conclude this? Yeah.
Sorry.
Can you conclude this?
Yeah, we can conclude.
Okay, thank you so much, Kerala IT. Once again, thank you so much for giving this opportunity to conduct this webinar. It was a nice session. I hope all of you get used with this webinar, and I hope all of you have a wonderful session. Thank you.
Thank you.